Hi, I'm Yusheng Huang. I'm from Concordia University. I'm a PhD candidate now and supervised by Dr. Amin Hammad. The topic I'm presenting today is practical consideration and case studies for implementing autonomous UAV videos collection of construction activities. So now we are talking about digital construction, and with the more needs on the digitalization, we are trying to deploy sensors on the construction side, and like a new trend now is to deploy the cameras on the construction side because being propelled by the computer, like the advancement of the computer vision techniques. Like conventionally, we try to install cameras on the construction side, like to install a fixed camera, or maybe we try to capture the videos with some handheld cameras. However, with these two approaches, there are some limitations, there is low feasibility and also low productivity. So that's why we are trying to deploy the UAV. We use the camera-equipped UAVs to collect videos from the construction site. Previous studies have tried to like do some contributions to make the uh, data collection, the video collection autonomous. And then, however, like their path planning and also the viewpoint optimization is mainly based on, focusing on the tasks for like inspection or maybe to do something about 3D reconstruction in order which are focusing on the static objects. So there is a need of how we can use the UAV to automatically collect videos from the construction site to capture some information from the dynamic objects like the workers and activities on the construction site. So in this to this end, in our previous work, we propose a method called uh, simulation-based optimization path planning for camera-equipped UAV that consider the location and time of the construction activities. And this method actually basically consists of three modules, which is first the simulation environment preparation modules, which define the workspace according to the high 40 LOD beam. And then we identify the solution variables and to define the search space for different workspace. And at last, we do the viewpoints optimization to identify the best viewpoints. The top ranking viewpoints that can have a good view of the target area. And with these viewpoints, we try to use and do another optimization to solve the generalized traveling salesman problem to get the optimized path. And we did a previous case study to do the path planning, and these are the results. So it shows the basically the oh, how can I basically the optimized path at different durations. And however, this method was doing well in the virtual environment. And we want to deploy it to the real scenarios. However, to bring the stuffs this from the simulation to the real world, there are multiple limitations we need to resolve. So and also some practical considerations. So here in this work, our objective is to identify the practical consideration before implementing autonomous UAV video collection of construction activities. And we consider them from four aspects. First, the technical requirements, the safety requirements, and legal regulation compliance, and also last, the data requirement, which is the computer vision requirements in our case. And we develop a workflow for implementing an effective video collection of the construction activities using this UAV. And we also apply a case study on the real construction site to validate the applicability of the workflow. So talking about the technical requirements, so we have first is some hardware requirements like the camera quality and the specification of the cameras. Usually we use the UAV with 4K camera. In most cases, it will be sufficient because enough to capture some details from the construction site. However, maybe in some special cases, we may want some camera with high zooming capability, or maybe we want some special camera in some case of inspection, like infrared camera. And we also want the reliable antenna and navigation system. And the third thing for the hardware requirement is about the operational range of the UAV. So here you can see from this example, for some small construction site or medium-sized construction site, we don't need, like in this case, we may not need to consider these situations. However, in the road construction site, like which is very large, so we need to think about the operational range. And also the battery life. And most of the UAVs can fly for like 30 minutes, but in some cases we may want to do a longer operation. So this tethered solution may be like an optimal solution. And also we want to support the. Oh, I'm sorry. We want to have some software requirements like the API and the simulation tools. So here we show the API of the pre-flight planning in the model that we used. And the next thing is the simulation tools. So this is a simulation tool that we developed to like from our previous study that to do the path planning. We will talk about it later. I will have a more detailed case study to show the details. And also, we want to talk about the safety requirements. So first of all is the risk assessment. We need to do some risk assessment to the construction site. As shown in this example, like we want to identify all the risk area or the area that are like not allowed to enter. And then we want to have a good contingency plan, and also we want to think about the requirements related to the UAV specifications, like the accident prevention functionalities, and also we want sometimes we want the lightweight UAV to avoid some distraction to mitigate the effects, and also to mitigate the distraction to the workers on the construction site. And the first thing is the compliance with the legal regulations. So we need to properly register UAV and so far and so forth, and have a pilot license, and we need special permits for controlled airspace according to the local laws. And also we want to protect the privacy of the workers, but because we have limited time, I wouldn't explain it in detail, but this part will need a lot of work during the implementation. And also at last, we want to have a good documentations. And so the fourth thing is the computer vision, the data requirement, which in our case is the computer vision requirements. So as we mentioned before, the camera specifications. And the second things to talk about is the distance to the target. As shown in this example, like in this construction site, like for the near field workers, if we want to identify the activities of them, it is easy. However, for the far field worker, I mean, if we have zooming in, still we can't recognize what is going on there. And we want to have a good angle of shooting. So still with the example of activity recognition, we don't want a top-down view if we want to like capture the activities of the workers. So we want a good angle of shooting. And also we don't want like a side view, which may have occlusions. And at last is a stable field of view to avoid motion blur. And this can be done by hovering the UAV. And from our previous experience and some other works, the hovering can provide the best result for activity recognition. So this table shows lists all the practical consideration that I mentioned before, and need to mention that there are always connections within them. And here in this figure, I show the implementation workflow, and I will talk about it with some details in our case study. So in the first part, we prepare the simulation environment, as mentioned before, and then we bring the data, we integrate the GIS data into the game engine in Unity, and then we define the workspace and define the safety buffers, I mean the dangerous areas. Then after that, we select our UAV. So these are the three UAV models that are available in our department. So we have the mini one and then the medium one. This is with AI capability, and this one with some like customization capability. And then at last we select this small one because it has lightweight, so it make it easier for us to get the permit from the government, and also it has less distraction on the site. And yeah, this one itself is a good one with high quality camera and some functionalities to prevent safety issues. And then we do the simulation to optimize the viewpoints. And after that, we do the virtual verifications to verify the holding points is focusing on the designated area, and also the flight path is free of risks. Then with this virtual path, we extract this path into a KMC file and bring it to the UAV. And at last, we do the on-site verifications. So as shown in this video, we compare the virtual verification with the on-site verification. So this is the camera's view in the virtual environment, while this is in our implementation on the construction site. Yeah, I hope I can show, because we have limited time, I will skip this one, because actually I want to show you the whole path, but I think the time is limited. Yeah, so to summarize, this work proposes a workflow for achieving optimized and efficient video collection using autonomous UAV. And it also highlights the key practical consideration for implementing autonomous UAV-based video collection of outdoor construction activities. And mapping, this work maps the practical consideration in the implementation workflow, and the result of the case study demonstrates that this workflow is effective in generating operational plan with optimized waypoints. And these are the future work. We will do more tests in some other construction environments, like more complex environment. And we also want to develop some methods to address a limitation, which is like the workplace may change, like not according to the schedule. So we want to deal with this thing. And this is the end of this presentation. Thank you.